This is Daniel speaking on behalf of Knowledge Maps, a new DTR project from winter 2018. This is my quarterly status update, and I look forward to presenting my findings. So I started off Knowledge Maps with just this user interface, and what a Knowledge Map is it's essentially a organizational tool that, given professional examples and tutorial examples of web features, so different features on websites, you're it's an organizational tool that invites users to be able to group the features or the examples by whether the feature, what the type of feature it is, as well as the approach, so the implementation approach. And the idea is that by considering the examples in context of other examples and kind of constructing a conceptual map for each one of the examples, you get really great affordances and really great learning that if you're ever faced with a similar obstacle going forward in a professional environment, you would have no trouble figuring out what particular essentially feature to implement or what particular coding practice. So it's kind of based on Rails philosophy, which is to use professional websites and professional resources to teach you how to become a better coder. So I started off with this interface, and I actually built a little tech interface here. So let's say this kind of just looks like a very low fidelity knowledge maps interface that I built during the first week. So let's say I want to find another scroll bar here, and let's say I want to do BBC News feed. You're able to add an example here, and you're able to drag it from the new examples down to the scroll bars here and kind of drop it. It's low fidelity, but it's a work in progress. So that's my technology user interface component currently. Now, really, once I started diving into the project, I was presented with a couple motivating questions. So the first motivating question is, what exactly is a knowledge map, and what can make it useful for aspiring professional programmers? I thought that I needed to understand it, and that really the key to it is constructing a conceptual map, and just that when you're able to examine so many professional examples and kind of break them down into little pieces and compare them, you're able to understand more facets of every single feature that you're analyzing or putting in question. Uh, there are two other questions I considered. The very big one was, what are difficulties and obstacles and pain points, for lack of a better word too, that users experience when either performing representative tasks of constructing a knowledge map or generating their own map. And a follow-up to that, which I explored later this quarter, was, what are methodologies in which we can make the knowledge map generation process easier and smoother? So based on my learnings, what can we do? So I started off with my first user test, and my first user test kind of just really hit very surface level issues. So I started off by pulling code snippets off of jQuery UI, which I used to create this low fidelity prototype. And I essentially had a couple of representative users open up the source code and kind of just play around with the interaction and try to make sense of what the source code was doing here. So as you can see here, it's a draggable feature for jQuery, or for example, a droppable feature, which allows you to drag a box and drop it in. And essentially, the whole purpose of this study was I tried to, from a very surface level, figure out what was really difficult to users. So for example, I asked them, well, how would you classify the relationship between draggable and droppable? And most of them will tell me, well, droppable uses draggable, but they wouldn't be able to tell me anything more around that. So I think what surfaced as a really big obstacle and a couple of surface level pain points through the study was that it's very difficult to analyze code, especially for novice programmers who have, we classify them as programmers who have only programmed with a couple hundred lines of JavaScript at most at one time. And it's very difficult to analyze code on the spot, especially in some cases jQuery can be quite cryptic for ones who do not have jQuery experience. And they told me that it was also very difficult organizing code, so that there was only so much understanding that they can really extrapolate from it. So based on this, I learned that, well, first of all, I need to pick examples that are very similar, but similar in the sense that they appear almost the same on a website. This was an interesting start because this was an existing resource, but I really had to go out and source examples that are really simple and look the same, but are really implemented differently. So that led me to my second kind of study, which culminated in also my in-class status update, but I learned different things from each one. So here we have two carousel examples. You can see that they're vastly different just by the type of code that's present, but they kind of work relatively similarly. You're just cycling through a lot of nice images here. So here I'm cycling through an image as well, and it's pretty great. Um, but you notice here that there are differences for sure. So this carousel is using the CSS display property, none and block, which shows and does not show elements respectively. And just uses relatively vanilla, as I would like to say, HTML and CSS. On the other hand, this implementation is particularly interesting because it uses Pug instead of regular HTML, and it uses Stylus to do all of the styling that's responsible for cycling through a carousel, and that there's no JavaScript whatsoever. So I took these examples together, and what I did was I gave my users a sample knowledge map template. So here we have features, carousels, and sliders, as well as buttons, which I initially included but took off eventually, just to focus on the two. And we have approaches, which I initially started by having them categorized by what language I thought, or had them think was the most important behind driving an interaction on a particular feature on the web page. And I realized from this and from the knowledge maps that were generated, that there really wasn't a whole lot of sequential thinking. That really what users were doing in the beginning was that they were just kind of going through the examples one at a time, and then just kind of comparing. For example, if I did 1, 2, 3, 4, they would just compare 1 and 2, and then 3 and 2, and then 4 and 3, just kind of sequentially when putting them on the knowledge map. So they wouldn't really think about it with regards to all the other examples. And I thought that that was something that really proved to be a problem. I think that one of the obstacles that they were facing was that they were losing affordances and potential knowledge gain by just comparing it sequentially. So that really led me to one of my design arguments that I realized was that one of the reasons why it's so difficult to kind of extrapolate information off a knowledge map is because sometimes when you present examples in such a certain list, so for example, let's try like right here where I'm just numbering them examples 1 through 7, the natural tendency is to go from examples 1 through 7 and not really think through what example 7 and example 1 are because there's so many examples involved. So one of my design arguments became, what if we had users, what if we essentially had scaffolding where users would be asked to compare each one of the subsequent examples with all of the examples before adding it. And I think that really this taught me that not thinking in between was one of the practices that really separated between the novices and the experts. So I actually have a expert knowledge map here. And if you notice, and during my recording and my interaction with the expert who created a knowledge map using my template, he said he did a really good job comparing in between the examples. He had a really good grasp of JavaScript and specifically the carousels I was testing on. So I noticed a lot that he was going through examples and thinking how each one of the approaches and examples fit within approaches rather than just kind of just placing them on in a general category. And I really think that this is a big potential that we could scaffold users to really practice expert strategies here. So I think that was one of my big takeaways. My other takeaway from my status update was that I really wasn't too clear given the template here. So given this template, what an approach was. I wrote an explanation saying an approach is the way a user implements code. But given such a diverse group of both skill and specialty of students within DTR, I think the common issue was that we, no matter what they ended up producing, you can see here that I don't really know how to categorize the approaches or always tell what is doing the work. So that relates back to a challenge that it's difficult analyzing code, especially very foreign code. And it's also difficult because you don't really know what an approach is, and it's very difficult for you to continue from there. So I really think that the two obstacles I faced was the first one was trying to get users to scaffold users to practice good practice of thinking between examples, and also having them understand what exactly an approach is. And I think really after the status update, I did a couple of changes. So the first thing I did was I tried to seek as simple examples as possible. So no longer did I use examples that had Pug and Stylus and no JavaScript because there was too much of a disparity between the two examples. But really, I just tried picking examples that seemed very similar to each other. And that led me to decentralize myself from the process of creating a knowledge map and more so the process of becoming an expert. So I actually took around 20, 22, 24-ish examples, and I actually made a knowledge map myself. So I made a conceptual map. So I know there's a lot to see on the screen. Oops. But essentially, I broke down a carousel, just JavaScript carousels, by essentially putting it from the need of a user. So if a user wanted to build a particular carousel, what are the different options and what are the different approaches to it? And I thought that if I understood the approaches, I would be able to source better examples. And sure enough, I was able to. So here, what I did for my last study was I took one example here where the active class is appended to another class in this particular approach. I took another one where CSS overflow property is used to cycle through the slides. And I took one more where you toggle the CSS display property. So without going into too much detail due to the time, all three of these examples implement particular carousels. They all look very similar. They function like the carousels that I showed earlier. It's just that the difference is very constrained. It's constrained in such a way where it's a difference where we want the users to be able to see by analyzing those particular examples. So that's what I did for my last study. My last study was really trying to take the three examples, and what I did for each person was I scaffolded them. I had them essentially tell me why, for every single one of the examples, why they thought the example was different. And sure enough, like for at least for this one example, they were able to notice that for one, they were using multiple classes to, or just one class to represent elements, that CSS has very many different display properties, and they were able to reflect that and accurately articulate that to me. So there is progress on that end, but I think what really needs to be a focus and one of my big constraints this quarter is asking why. So what I mean by that is for why will we have a case where we would want to use the CSS, display property none and block as opposed to a jQuery abstraction? And I think that's really one of the focuses I want to work on next quarter, and one of the constraints that I've just discovered is that how are we able to effectively use the design arguments on scaffolding users to be able to have them understand the why? Because once the users understand the why, they'll be able to gain a whole nother level and a whole deeper level of understanding. So really what I think was good this quarter was I was able to centralize a lot of the pain points. I was able to iteratively run studies and to improve every single one of my studies. I was able to really increase my knowledge of carousels. If you zoom out the map, there's a lot going on here. And kind of just come together and be able to source examples that I can confidently constrain a certain number of implementations to, a certain number of differences to, that I think would be useful for users to learn about. And I think going forward, what I really want to work on is I want to work on more so my interface argument. So how does the difficulties and my scaffolding translate to an effective interface that users find friendly and that users can really gain a lot out of? And really trying to figure out this why. How can we portray or display or scaffold information in such a way where the user is able to recognize the why between these three particular approaches and for web development in general. So that concludes most of my quarterly status update. I really enjoyed being part of the project this quarter. I'd like to thank my SIG group, my Rails SIG, as well as Haoqi and Nell for guiding me through all of this, and I'm really excited to see what this project has to offer. Thanks.